Okay, so we've assigned material and thickness to our model. We've assigned material and thickness to our model. So let's proceed with the mesh. Okay, so I click on the mesh to open up the details of the mesh below it. So you can see by element size, by default, remember I told you that the software, the simulation software, will divide that model that you have into smaller fractions. Okay, so when it divides it into smaller fractions, it will calculate for those small individual one, add it together to give you the final result. That's what meshing is. Okay, so the element size is the element is the small size that is going to divide it into. So the size, now you can set the size that you want it to be. So currently the size is set at 124.5 millimeter, which is what we have here. 124, that is the default, 124.51 millimeter. And when you scroll over the model, you can see this circle that is close to the cursor. That is the size of that 124.5 millimeter, but and you can change it. So if I should come to this element size and click on it, then type in 50 and say enter. Click on enter. See, you just, if I check the cursor again, you can see that the circle has reduced to 50 millimeter diameter relative to this size of this model. So it's trying to tell you how small, how the size of that 50 millimeter in this model. So as I was saying, that the default size was 120 something millimeter, and when you check, if I hover around the material or outside in the canvas, you see this circle that is close to my cursor. That is it's trying to tell you how big that size is. There's 50 millimeter. So it was initially at 124. So it was initially at 124.51. So if I should bring it, I can see how big the circle is, just to tell you how big that 124 is relative to the model you are trying to mesh. So I'm going to change it to, let's say, 50 and click enter. Now bring it, I can see I'm okay with this size. So I will now go to my mesh, right click on the mesh and say click on generate mesh. And wait for it to load. At the bottom here, just below that details of mesh, you see you see your mesh generating. You see the status bar here generating. Currently it's at 5%. So even when you are solving, it will be displayed here at the bottom of this your project section. Just below it, you see it generating. Currently it's at 5%, so wait for it to generate. So the smaller the mesh size, the more time it will take to generate. So if I had used like 1 millimeter or 0.1 millimeter for the mesh size, which will be very small, it's going to take a lot of time to generate. Okay, so whenever you are doing you are trying to look at the best possible outcome for your mesh. You can see our mesh has been generated. So if this Ansys is trying to solve this model now, it's going to solve for each individual. Let me select the element selector. It's going to solve for each individual element. You can see this element now is a square. So it's going to use the formula of a square to solve for this, assuming I'm looking for the area of this body now. It's going to, instead of currently there is no formula that will solve for this. Probably this is a simple body, so it might be able to solve it. But if you are working with a complex body, you might not have a formula that can solve the area of that complex body. So what Ansys will now do is that it will divide it into this smaller square that you are seeing here. So it will not solve for this one because there is a formula for square. So it will use that formula to solve for this square, solve for this one, solve for this one. If it's a triangle or a parallelogram, it will use the formula to solve for it individually. Then it will not add it together and give you the area of that body. So that's what meshing does. That's the advantage of meshing. That's why it's very, very important. So your mesh refinement will determine how accurate your results will be. So the more refined your mesh is, or the more good your mesh is, will determine how perfect your results will be. Okay, so now our mesh has been generated. So what's the next step? The next step is to add boundary conditions. So you go to your static structure, this static structure here, let's click on it and then insert. You are going to fix one end of this body and then apply force to the other end to see how stress will be distributed in this body and to see how it's going to be deformed. So under insert, you see this drop down menu, this menu here. I'll select fixed support. So let's click on it. Then you can see the details of the fixed support is now displayed here. So it's trying to tell us to assign the part we want to fix. So I'm going to use the edge selector. Currently it's at face. I'll move over to the edge selector. Let's click to activate the edge selector. I will select this edge. Let's click to select this edge and then click apply. Okay, you can see the one edge, this edge that we selected and we click apply on has been fixed. So we now have this edge is fixed now. So we are going to apply a force on this other edge. So you go to your static structure also. Let's click, then insert, then go to force. Okay, so we have force here. Let's click on force to activate it. So the first thing is to assign the geometry where we want to apply that force. So we are still at edge selector. So I'll select this opposite edge. Let's click on it, then click on apply. Now our edge has been selected. Okay, so you can see our edge has been selected. So the next thing is to add the magnitude. How many force Newton do we want to add to that? We are going to say 100 Newton. Click on enter. So currently a force of 100 Newton has been applied to this our body. But when you look closely at it, you find out that the force was applied in a direction that we don't want. Currently, we have fixed this edge. Okay, yes. Currently, we have fixed this edge. Okay, so we want to apply the force in this direction. But now the force is being applied in this direction, which is we don't want. This is not what we want. Okay, this is not what we want. So this isn't what we want. This is the type of force direction we want in this our analysis. So how do we do that? Instead of cancelling it and going back again, you can scroll down in this your details for that force, then go to the next one. After the magnitude, the next one is the click to change direction. That's the direction section. Then I will click on this and then it will be activated. It will prompt me to change the direction. I will select the edge I want it to face. I want it to face this edge. So I'm going to select this edge so that it will face this edge. But when you look at it, if I should zoom in now, you find out that it's faced in the opposite direction, but I want it to go in the right direction. That is the positive X direction. So I will use this box here to change it to the positive direction. Currently it's facing the negative. I want it to face the positive. Okay, this box here, just below here, close to these details here, this box here, you can see this side is highlighted red. That's why it's facing here. So if I should click on this one now, it's going to fix here, which is exactly what we want. And then I'll click on apply. Now you can see that our force is now facing the right direction. So we are okay with this. So the next thing is to what solution do we apply that? Do we only want these two boundary conditions, the fixed support in this edge to fix it in space, and the force to apply a force to this edge to see how this body is going to deform, or how this body will be stressed. So there is two things we are going to watch out for. So in our solution, we want to check just the deformation of that body and the stress distribution on that body. So let's click on the solution and insert, then scroll to deformation. Deformation is the first one. I want total deformation. That is how the body will deform in total. Then you click on solution, insert again, then go to stress. Then select the equivalent stress, that is the average stress. Then click on that solution and click on solve. Solve at the top menu here. In your menu bar here, you see the solve. Or you can, under your solution tab, you can right click on it and then click on solve. That is the two ways you can do that. Either you right click on solution, solve, and click on solve, or you go to the top of your menu bar here under your home section. You see the solve. You can now let's click on it to solve. Now it will start solving. Just below this details section, you can see it reading. Currently it's at 6%. You can pause it using this yellow button. You can stop it using the red button here. You can see if I hover around it, it says stop the current operation. If I hover around this one, it will tell me to pause the current operation or interrupt the current operation. So currently is loading. Is at 10%. So wait for it to get to 100% before you can view our results. So the more the mesh size, the more time it will take to solve your result. Okay, so before we view our result, it's still solving. Okay, currently it has completed the solution. You can see all there is check mark in all. Okay, there is check mark in all of our solution, both from the beginning, the model, the geometry, the mesh, the static structure, the boundary condition, and the solution. They've all been checked good. All right, so telling us, this is trying to tell us that our result is now ready. So what do we do next? Before we proceed to view our result, there are certain things that I would like to show you. So I want to show you, and it's very, very important. It is going to reflect in your assignment. So I want you to pay attention. It's still on mesh. So if I should click on mesh now and view the details of the mesh, remember we only talked about element size. Okay, so now we have our elements. So I promised you that we are going to explain this three. The node selector. Node is to select the node. That is the point where two elements meet, is the node. Just it's almost similar to vertex, but they are not vectors. This is not a vector. This is a node where two elements meet. Is what we call a node. Let me zoom in. Okay. Point where two elements meet is what we call a node. So then the next one is face selector. So this is a face. You are selecting the face. Okay, why the element select element to select the entire body of that element, or face, just like face selector here, we select just the face of the element. So that's how you select, use those three selection filters. Then the thing I want to show you is under these details of mesh. If you scroll down to the last section, you will see statistics. This statistics is very important. It can help you keep control of how you the number of node and element that will be generated here. So currently in this my element, I have 507 node and 463 elements. So remember I told you the point where two elements meet is what we call the node. The point where two elements meet is what we call the node. So currently we have 507 node and 463 elements. Okay, so this is the element. Each of them is element. So you have both square elements, you have quadrilateral element, you have triangular element. There are several types of elements. So in our advanced class, we'll be going into details on this meshing system, the type of element that we have, and all these things. So all these things we are going to go into details in our advanced classes. So this is very, very important. It will reflect in your assignment. So after this class, I'm going to drop the assignment in the group. All right, I'm going to drop the assignment in the group immediately after the class, along with the recorded session. So this thing is very, very important. So before we proceed to viewing the result, I want to drop the. Okay, so I was talking about the nodes and elements. So I said if you should click on your mesh in your project section, click on the mesh, the details of your mesh will be displayed here. Details of your mesh will be displayed. So you scroll down to the last section, which is the statistics. Your statistics. If you go to your statistics, you can see the number of nodes that you have on your mesh and the number of elements. Okay, like I said, nodes is the point where two elements meet together. That's your node, and you can view it using your node selector here. Node. If I should activate the node selector, you can see the node is the point where two elements meet. There is your node. Why the elements 463 elements is each of these elements here. We have different size and shapes here. You can see this is your element. So this element in total is 463. Why the node in total is 507. If I change it to 25 millimeter, you generate mesh. Then you come down again and write down the number of node and element. That will be your assignment for tomorrow. So let's see if okay. Okay, that will be assignment. So this is your assignment. You are going to do it 5 times, 5 examples. So using the same model of your choice, any model of your choice, you can download from the internet. You can design yourself if you know how to design using any CAD software that you like. So import it into Ansys, then using the element size of your choice too. You can decide to go with 1 mm. You can decide to go with 10 mm. You can decide to go with 100 mm. So by changing the element sizes, you see how fast. You see how the element size affects the operations of your meshing in your Ansys software. So I want you guys to try meshing using different element size. So for the first one, you can use 10 millimeter. Second one, you can use 50. You can use 30. You can change it any element size that you want, or any one that you generate. Any element size that you use and you generate the mesh, just come down to whenever you generate the mesh and it generates successfully, you come down to statistics and take note of this node and element. Write down the number of node and elements under that element side. You can see number of element, number of node. You come out and write it 463 and 507. Then you now go again, use another element size. You now use another element size here under this. You click on mesh into element size. You change it again. Let's click and change it again. Let's say 100 mm or 25 or 30, any number you want. Then you generate. When you've changed that, change it like 30, and then click enter. Then you come to mesh. You come to mesh, right click, and then generate again. When it's done generating, you scroll down to the statistics. By then the nodes and element would have changed to reflect the new element size. Then you now come down to this table and then write down the new number of elements and the new number of nodes, and you also write down the element size that you used to generate them. That's what you are going to do in 5 places. So that's 5. That's why I wrote example 1 to 5. So this will be your assignment. Hope it's very, very clear. Any question as regards to and the assignment part, this is what you are supposed to do. Okay, I dropped the table. I'm going to provide the table for you. I'm going to provide the table. Okay, this class ends in 15 minutes, so let me round up. Okay, so I provided this table for you. So I said you are going to need a model, any model of your choice. It could be a simple box, it could be any shape, or it could be a shelf, a simple model, any model you want. I will advise you to use a simple model. Don't use something complex like a car model or a bicycle or something. I don't want something complex. So something simple like a box, simple stuff like that, simple geometry, a circle, a ball, stuff like that. You are going to use the same model for the 5 examples. So when you get a simple model, either you design it yourself in any CAD software and import it to Ansys, or you design it in Ansys CAD softwares, or you can download the one that they've already designed from the internet and import it in your Ansys and now use it to do this assignment. Okay, you only need one. Right? So what you will now do is that for every example, like example 1 now, for every example, you just come to your Ansys Mechanical. Okay, click on mesh. Okay, when you click on mesh, the details of the mesh will be displayed below. So when you click on mesh, you come to your element size. That is for this first one. So you can see element size, number of elements and number of nodes. So for this element size, choose any element size of your choice. So you might decide to go with 10 millimeter, assuming you want to go with 10 millimeter. You come here and type in 10 millimeter. Type in 10 millimeter and click on enter. Then when you click on enter, you go to your mesh again and generate it. You want to generate the mesh using that 10 millimeter element size. So once you generate it, when you are done generating, you scroll down to statistics. Under statistics, you see the number of nodes and the number of elements that was generated using that element size 10 millimeter. So you now come to your table now and fill under element size 10 millimeter. Under number of elements, you now write down the number of elements that was generated. Under number of nodes, you write down the number of nodes that was generated. You will repeat this process 5 times. That's why I wrote example 1 to 5. So for the first one, you use 10 millimeter. You will not change it for the second one. You will not change the element size to something different. Let's say 15 millimeter, 20 millimeter, 5 millimeter, any element size of your choice. Okay, so you use different element size. Use 5 different element size. So when you change it now, you generate again and then come down to nodes and statistics. You check the nodes and element. You now use it to fill your table. It's as simple as that. You can see I told you earlier that the smaller your element size, the more time it will take to generate. So if I had said, let's say 200 millimeters, let me change it. Let me stop this and change the element size now. Let me stop this and change the element size now to 90 and say enter. Okay, and then come to mesh and generate mesh. You see that it will take faster. We were using 10 and you know how long it took us to solve. Just watch how fast this one will take. Now you can see now it has done 100% done. Element size 90. You scroll down to statistics. You now see the number of statistics. Node will now be 237 and element will be 210. Then you now come here and write down element size 90, node 237, node under node, number of node 237, under number of elements 3 something I think. that number of 210. You now come down here and now write 210. That's what you are going to do. Okay, let me use this this to show you. Okay, you come down to element and type in 90. Then come to your number of elements and say 210. Then come to number of node and say 290. Assuming it's 290 we have there. What do we have here? Okay, 237. Sorry. So we go back and say 237. Say 2. Sorry, I have to clean this. 237. Right, this one is 210. 210. So that's what we got for 90. You repeat the same process again for. You repeat the same process for this. Let's say you change the element size now. Go to your mesh again. Click on this mesh. You are still in the mesh. You come here and change it to 95 or let's say 98 and click enter. Then you come to your generate your mesh for that 98 and say generate mesh. To wait for it to load. Okay, the larger the element size, the lesser time it will take to generate. Okay, so but the smaller it is, it will take more time. So if your element size is small, it will take more time. So now it has generated for 98. Then you come to your statistics. Node is 223, element is 200. So you come here and write under the element size, you say 98. Then node 223 and 200. 223 and 200. All right, 223 and 200. So you say this is 223, and this one is 200. So as simple as this, it's not hard. It's a very simple something. I just want you to understand how your element size affects the node generation and the element generation, and how it affects the entire process of generating mesh and discretization of mesh in your Ansys software. So that's why I gave you that particular assignment. Okay, so I believe that explains the assignment for you. So I just explained the assignment for you. Very, very simple. So let's go ahead and view our results. So no, I'll have to take it back to 50 because we are working with 50 millimeter element size. 50, hit enter, and then generate for this mesh. When you generate, and after generating, we are going to solve. So do you have any question? Any other question? Any other question? I believe you all understood the assignment, and I believe you all have filled your attendance. So I don't want a situation where after the class some persons forgot to fill or they're not able to due to network and probably one or two reasons. Okay, our mesh is still generating. See how long it's taking. So I think I'm going to close this so that it will use a value that will make it very fast for us. I'm going to use 100. Hit enter, then generate again. So I want it to be fast because our class will soon end. So our next class will be on Friday. So we'll be rounding up on Friday. We'll talk more on structural analysis on beam structures, or how stress or load condition affects the deformation or distortions of beam, and the stress distribution, the stress and strain distribution of them. So we'll talk more about that in details on Friday. We'll be rounding up that Friday. So after that, probably in our advanced class, we are going to go deep into Ansys finite element analysis in details. Okay, they will touch about every other aspect of finite element, like the thermal analysis, the explicit dynamic analysis, the modal analysis, the transient analysis. Okay, this analysis that we are doing now is static, is steady. The load condition does not change with time. Or if you are doing in a transient condition, if you are running a transient analysis, you are going to you are essentially trying to say that the load condition will change with time, that the load is not constant. Okay, so now our solution is ready. So if I should click on deformation to view it, you can see how it deforms. Okay, let me move this aside. You can see how it deforms. This is also you can click on stress, equivalent stress, to see the stress distribution. So the maximum stress here is 0.13 megapascal. The unit is megapascal, so 0.13 megapascal. And then you have the maximum stress in this area. So you can view that. Okay, let me see. All right, selection. Okay, I'm looking for something. Okay, yeah, can view the maximum stress by clicking on this maximum here. Click on the maximum to show you where you have the maximum stress. Okay, you click on the minimum to show you where you have the minimum stress. So you can zoom in to view them properly. Okay, this is where we have the maximum stress. This is where we have the minimum stress. All right, this is the stress distribution. You can also use your animation to view how the stress is being distributed during the distortion, because we fixed this edge and started extending this one, apply the force to this one. So we can essentially trying to say that this one is fixed to a body or a wall, while this one is being stretched. Okay, because we apply the force of 100 newtons. So if I should click on this play button here, they are on the graph to see how the model distorted. Okay, how the stress is being distributed during the model distortion, or when that force is being applied. Okay, if we can also do that for deformation and see how it deforms, all right, when that force is being applied. So if I should click on the play button, you can see how it's deforming, right? You can see how the model is stretching and deforming. Okay, so we have maximum deformation on this edge with a value. The value is actually very, very small. Okay, so we have maximum deformation here. So let me stop this. Click on maximum deformation. Maximum. We have the maximum deformation on this edge. All right, so that should conclude our class. It's now time to attend to questions. If you have any other questions as regards to what we did today, you are free to ask before we conclude, before we call it a day. So we have less than 5 minutes now. So if you have any question, now is your time to ask. Remember, I promised you at the beginning of the class that this class will just be 1 hour, so I just set it to 1 hour. So I don't want to waste your time, it's already late. So if you don't have any question, we'll call it a day. So I'm waiting for questions before we end the class. Let me stop sharing my screen. Okay. Someone say, how do we save our work? How do we submit our assignment? Don't worry, for the assignment, I will provide it. I will send it to the group. Ayomide, the assignment, I'm going to send it to the WhatsApp group. Okay. Then I explained how to submit it. The same way you've been submitting assignments in other courses. Okay. When you generate a mesh, you can screenshot the interface of that your Ansys mechanical, and then use it to create a post on LinkedIn, adding those hashtags, add tag us, and using all those hashtags also said. All right. Sophia asks, what can cause an error in the solution? There are several reasons why an error, probably poor mesh, or the boundary conditions are not accurate, or you did not apply it properly when you are supposed to select an edge. You selected a vertex, stuff like that. It can affect it. It can affect the error. There are several reasons, and whenever you get an error, there's an error message. You can read the error message to give you an idea. Sometimes the error messages are not 100% clear. You might not understand what they are saying there, but it can give you an idea on where the problem is coming from. Okay, Teslim, you have a question. As you can ask your question, unmute your mic and ask your question. Teslim, you're raising your hand.
Good evening.
Yeah, good evening.
Good evening, sir. Thank you very much for the presentation. Is it possible to import a model from AutoCAD to Ansys? I mean,
yes, you can import. Ansys accepts almost every file format, for every model format from other software, SolidWorks, Fusion, AutoCAD, Inventor, OpenFOAM, even this new one that just came out now that is now popular. I've forgotten his name. A new CAD software. There's Fusion accepts a lot. Sorry, not Fusion. Ansys accepts a lot. Okay. So, but if sometimes you might have an issue, probably I don't know. Sometimes with this new release, I don't know. You might have an issue attaching. Anytime you encounter any error where you have to, when you are importing your model in Ansys, anytime you are having any problem with importing that model and you are getting an error, all you have to do is convert that model to a step file. Okay, convert it to step file. I think all CAD software allows you to export as step files. When you want to export or when you want to save in your computer, change the file format to step, right? It will save you that stress. That's why most times I use step files, but it's Ansys still accept every other CAD format. All right, so I believe that answered your question. All right,
Thank you very much.
all right, you're welcome. Any other question? No question. Okay, I guess we'll call it a day. So thank you very much. Our time is almost up. So I appreciate you making out the time to attend this class. It actually boosts our morale. Those of us that are trying to organize this training for you, NSE, Royal Grant, is trying to tell us that yes, you engineers are actually interested in what we have to offer. And I really love the seriousness. I love the questions. Anytime you have any questions that you encounter any issue, don't just drop them in the group chat, and they just drop them. I will attend to them whenever I see your question. So thank you very much again for today, and I have to call it a day. It's almost time. Ayomide, you can drop your question in the group. Saying the call will end.